Hello and welcome. In this video, I'm going to go over the Pico W's hardware, setting up MicroPython, and getting a coding environment set up. After that, I'll set up a program that will blink the onboard LED every 2 seconds. As always, if you like the video, please tap the like button and consider subscribing. With that said, let's get started. What is the Pico 2? The Pico 2 is the second generation of the Pico family of microcontroller development boards from Raspberry Pi. It is a single board with an RP2350 microcontroller, along with 40 GPIO pins that provide I2C, SPI, UART, and other I/O options. Additionally, there is a built-in LED and temperature sensor, and if you opt for the W version, it has both Wi-Fi and Bluetooth. So what is a microcontroller? I'll quote the definition from IBM. A microcontroller is essentially a small computer on a single chip. It is designed to manage specific tasks within an embedded system without requiring a complex operating system. It contains one or more processor cores, RAM, some sort of programmable storage, and peripheral connectivity such as I2C, SPI, and UART. Basically, it's a computer on a single chip, but it doesn't run a heavy operating system such as Windows, macOS, or Linux. There are two variations of the Pico 2 available at the time of this recording. The first is the Pico 2, which is the basic model with no Wi-Fi and Bluetooth. The second is the Pico 2W, which includes Wi-Fi 2.4 GHz that supports up to Wi-Fi 4 or 802.11n. It also includes Bluetooth 5.2. There are some variances in the board's layout between the two models. These are minor, but they are there. They include different locations for the debug pins, the Wi-Fi and Bluetooth chip on the Pico 2W, whereas the Pico 2 has a big Raspberry Pi logo. Some other chips and parts are in slightly different spots, and some additional parts are on the Pico 2W, but nothing that impacts the use. Lastly, both Pico 2 models can be bought with or without pre-soldered GPIO pins. Some suppliers may even solder on the pins for the debug headers. Now, let's move on to setting up MicroPython on a Pico 2W. So what is MicroPython? Here's the definition from the Raspberry Pi Pico website. MicroPython is a full implementation of the Python 3 programming language that runs directly on embedded hardware such as the Raspberry Pi Pico. You get an interactive prompt, the REPL, to execute commands immediately via USB serial and has a built-in file system. In addition to the base MicroPython functionality, the Pico port of MicroPython includes modules for accessing low-level chip-specific hardware. Okay, let's get started. To begin with, you'll need to download the version of MicroPython that is designed for the Pico 2. Go to the Raspberry Pi website using the link in the description and download the version for your Pico 2 or Pico 2W. Once you have downloaded it, connect the Pico 2 or Pico 2W to your computer, be that a Mac or Windows-based system. You can also do it on Linux as well. To do that, you'll need a USB cable with either an A or C connector to go to your computer and a micro-B connector on the other end to go to the Pico 2. First, connect the cable to your computer, and then before you connect the micro-B connector to the Pico 2, press and hold the boot cell button on the Pico, and then plug the cable in. Once the Pico 2 shows up in Finder on macOS or File Explorer in Windows as a mass storage device named RPI-RP2 or RP2350, release the boot cell button. Finally, copy the file you downloaded from the Raspberry Pi website by either dragging and dropping it or copying and pasting it to the Pico 2. Once it has finished copying, the Pico 2 will disappear from the Finder or File Explorer. This is normal behavior as it is restarted. It will not show up as a mass storage device after it is rebooted. The Pico 2 is now ready to be programmed using MicroPython. Let's now take a look at how you can develop programs on the Pico 2 using VS Code. To begin with, if you don't have it installed, download VS Code from code.visualstudio.com and run through the installation. You will also need to install Python as well. You can download that from python.org for your operating system. Lastly, if you're running on macOS, install the Xcode Select tools by opening the terminal and running xcode-select-install. Once everything is installed, run VS Code. Then go to Extension. You'll need to install the following extensions to enable VS Code to connect to the Pico 2. Python and Raspberry Pi Pico. A number of dependencies will also be installed with them. This will take some time. I've already done this to save some time though. Once all of the extensions and dependencies are installed, close and reopen VS Code. I found that the Pico extensions don't run properly after they are initially installed. Now, let's make a little project that can run on the Pico 2. First, click on the Raspberry Pi Pico project icon. Next, click on New MicroPython project, give it a name, and set the location for where you want to save the files on your computer. Leave the version of Python as it is, and then click on Create. A new window will appear with the project files that it created. You can ignore the .vs code folder and the .micropico file as they won't be getting modified. Open blink.py. This file is a program that will blink the onboard LED on and off every second until the program is stopped by pressing Ctrl+C on your keyboard in the terminal at the bottom of VS Code. Just to go over what the code does, at the top we've got two imports. First one will import pin from machine, and the second one will import sleep from UTime. Next up, we're going to specify which pin we want to use for our GPIO connectivity. In this case, the LED has its own dedicated pin, but rather than putting a pin number in, they just put LED and it makes life easier for everything. Next, we're going to do print LED starts flashing, so when the program runs, it's just informing you that we're just running this program that is going to start flashing the LED. And then we're just going to go into a while loop, which will never end until you actually do Ctrl+C. And all that will do is toggle the pin, and every second it'll toggle the pin back to what it was before. So effectively, it'll just toggle it on and off. So the LED will be on 1 second, and then off, and then on, then off. Rinse, repeat. Then if we do a Ctrl+C, which would trigger a keyboard interrupt, the program will break from the while loop. The pin will then turn off. So in this case, if the LED was on, that will now be off. And then on the terminal, it'll just print finished. Now, before you run it, go to the line that says sleep with 1 in parentheses and change the 1 to a 2 and then save it. This will change the blink interval from 1 second to 2. With that done, right-click on any empty space in the code editor and select Run Current File on Pico. If you look at the Pico 2 board, the LED should now blink on and off every 2 seconds and the terminal says LED starts flashing. To stop it, click in the terminal and press Ctrl and C. The program will now end. If the LED was on at the time, it will be turned off. Now, if you want to upload the file to the board, you can do so by right-clicking an empty space in the code editor again and click on Upload File to Pico. Don't do this at the moment, because if you do, the program won't run when the Pico starts. Instead, in Explorer, rename blink.py to main.py. You can then upload it to the Pico, and when it starts up, it will blink the LED. The reason for this is that the Pico 2 will look for a file named main.py when it starts up and run it. If it can't find a file named main.py, it will not run anything. Once the file is uploaded, close VS Code, as this will stop the program from running. Unplug the Pico 2 and plug it back in again. The LED will now blink as expected. And that's it for this video. If you got value from this video, please drop a like and a comment and consider subscribing, as I'll have some more Pico content out in the near future.